Alright, silly people, here's the situation. We're going to be launching a satellite into a circular orbit around the Earth so that it orbits the planet once every t seconds. And first of all, we do have to show that the altitude above the Earth's surface of said satellite has that form there. Um, so I did just solve this in LaTeX before I even started recording. So what I did is I just started with the equation for centripetal force of an object with mass m, and then equated it to its gravitational force uh, by Newton's gravitational force equation, um, and then did a little bit of algebra on it, and then use the fact that the velocity of the satellite will be the circumference of its orbit divided by its period t, um, to then plug that in and then do a little bit more solving, just a few algebra steps to get to h equals the form that it was. So I don't think it's incredibly complicated. You could do that in Physics 1, I think. Um, but now we have to write a program that's going to ask the user to enter value of t and then calculate and print out the correct altitude in meters. So um, we're going to do this from scratch. We're going to have to do a t equals float input, and then enter time interval in seconds. And yeah, seconds should be fine for now. That'll do. Now we need to have it calculate the altitude. So this is going to be just h equals, and then we're going to do in parentheses. Oh, we have to define these constants actually. So g equals 6.67, e negative 11, and m will be 5.97, e 24, and r equals, it does give it in kilometers, so we'll have to multiply it by 10 to the 3, so 6371 times 10, let's do it in parentheses, 10 to the 3 to get it in meters. Okay. Now we can write the formula for h, which is g times m times t, in parentheses t squared, and then divided by, in parentheses, 4 times, in parentheses, pi, which let's just use 3.14 for this. That should be plenty of digits, and that is squared. And then outside of that whole thing, raise it to the power of 1/3, and then subtract r. And I think that should work. So let's try it out. I think it's ready to run. Let's give it many seconds. Like, let's do 3,600 seconds, or 36,000, I guess. Okay, it didn't print out h. Of course, I need to have it print the altitude is, and then h, and then meters, right? That should be fine now. Let's give it another run. Let's do 36,000 seconds, and it gives us an amount of meters. That's fine. Now we have to use the program to calculate the altitudes of satellites that orbit the Earth once a day, once every 90 minutes, and once every 45 minutes. So let's just take this guy and then make another cell to calculate specifically 24 hours So like 24 hours times 60 minutes in an hour times 60 seconds in a minute should give the correct time interval. So, bam, that would be the altitude. It wants us to do 90 minutes as well, so we'll do another code cell with that, where we just switch this for 90 minutes times 60 seconds. Spits out that altitude, and then we're going to try one more of these guys. So it'll be, I don't know why I'm shut the hell up. Oh my god, no, don't generate code with AI. That's awful. Just do this guy again, but it's for 45 minutes. So it wants 45 times 60 seconds. So that altitude, it gives a negative value. Okay, so that means that there isn't a geosynchronous orbit of a satellite for 45 minutes because that wouldn't work. Uh, it would be in the ground, far below the ground, so that doesn't work. So technically, a geosynchronous satellite is one that orbits the Earth once per sidereal day, which is 23.93 hours, not 24. From what I could find, sidereal day refers to the amount of time for one rotation with the stars as your reference point, not the Earth's center as your reference point, which means you have to take into account the fact that the Earth is actually orbiting the sun as well as rotating. So that's why it's a little bit less. And so how much difference will it make to the altitude of the satellite? Well, we happen to know what that altitude was. We can calculate the difference between the two if we just put in 24 or 23.96, was it? 23.93. Then that's multiplied by 60 minutes and 60 seconds. So that altitude prints out something that is very similar, but we can calculate also what that difference is. So it's going to be just 35. Let's just copy down the number. This number here minus this number here. And it's going to give like a negligible difference. It's only only 82,175 meters of a difference. That's not that big. All right.